Good everyone, my name is Mr. Ademujimi. What we'll be looking at is differentiation. We're looking at differentiation. And what we'll be looking at, under this we'll be looking at direct method, okay? The second aspect is from the first principle. Okay? Direct method. And the second method is from the first principle. So let's look at the direct method. The direct method first. Direct method. That is differentiation from the direct method. Normally we have y to be equals to x raised to power of n. If y equals to x raised to power of n, x raised to power of n is what we call what? The domain function. The domain function. X raised to power n is the domain function. Of course, we know that n is the power, okay, which will be in what? In index form. Oh, that is the index. N is the index or what? Or exponent, or what? Which is generally known as power. So when you have y equals to x raised to power n, x raised to power n is what we call the domain function of y. That's the domain function of y. Okay? Domain function, or you call it what? Independent variable. Why this is what? Dependent variable. Why is dependent variable? Take notes. Y is the dependent variable, while x is what? Independent variable. Let's say, for instance, let's say if y equals to x raised to power 3, okay? Find y when x is equals to 3, or when x equals to 2. Find the value of y when x equals to 2. In this case, we can see that y has what to depend on what? On the value of what? Of x. Because we know that x is equals to 2, then we need to solve for y. So you can have y to be equals to 2 raised to power 3, that gives 8. Okay? So meaning that what? Y equals to 8 when what? When x equals to 2. So this is what we call dependent variable. Why x is independent variable, which is also known as the domain function of y. Of y. Okay? Let's move away from there. So we know that if y equals to x raised to power n, okay? So we can have a dy over what? Over the x will be equals to n x raised to power n minus 1. N x raised to power n minus 1. N x raised to power n minus 1. N minus 1 is the power. Okay? So minus 1 is constant. Minus 1 is what? Is constant. Okay? To differentiate this is just to bring what? The power will become what? The coefficient. The power will become the coefficient. That will be n x raised to power n minus 1. N x raised to power n minus 1, where n is the coefficient of this and n minus 1 is the power. So minus 1 is always constant. If you have to what? To differentiate, minus 1 is always constant. Please take note. Minus 1 is always constant, where dy dx is known as what? As the slope, or you call it what? Gradient, where y is known as what? The slope. The y dx is the slope, or what? Or gradient, slope or gradient. Please take note. that the y-dx is called slope or gradient. Okay? So from here now, we know that okay, let's look at this. Let's look at this. Find, differentiate with respect to x if y equals to x raised to power 3. Differentiate with respect to x if y equals to x raised to power 3. So we told that y equals to x raised to power 3. Don't forget that x is what? X is called the domain function or the independent variable. Y is what? The dependent variable. Okay? So we have to work to differentiate the dependent variable with respect to the independent variable. That is, we differentiate what? Y with respect to x. Y with respect to what? To x. And that will give us what? dy over what? Over dx, which is equals to x to the power of what? Of, that will become 3 x raised to power 3 minus 1. X raised to power 3 minus 1, that becomes what? 3x raised to power 2. Don't forget that the minus 1 is constant. Minus 1 is always constant, please. This is correct. But once you write this dy over the x, please don't put x raised to power 3 is not equals to. Okay? This is not equals to this. Not equals to this. Very wrong. Not equal. Not equals to that. Take note, please. Take note that this is not equals to this. Once you have y dx to be equals to what? Equals to the next thing is just what? To differentiate directly. Take the power to the what? To the front. Then take away 1 from the power. So if y differentiates with respect to x, if y equals to x raised to the power of 1 over 2, if y equals to x to the power of 1 over 2, what would this be? So we can have y equals to x raised to the power half. Okay, so differentiate this will be dy over what? Over dx. So the next thing after writing dy dx is to take the power to the what? To the front. That is, the power to become the coefficient. That becomes what? 1 over 2 times x raised to power 1 over 2 minus 1. To the front, that becomes 1 over 2 times x raised to power 1 over 2 minus 1. And this is still the same thing as 1 over 2 x raised to power minus 1 over 2. Okay? Which is still the same thing as 1 over 2 dot, that's times 1 over x raised to power half. That becomes what? 1 over 2 root what? Root x. That's the answer. That's the answer. That is, the derivative of x raised to power half is 1 over 2 root x. 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 Okay, 1 over 2 root x. What about this if you have something like this? If you have something like this, okay, differentiate. This is question 2, question 3, differentiate. Okay, if y equals to x raised to power 3 over 2, yes, x raised to power 3 over 2, find dy over dx. Find dy over dx. If y equals to x raised to power 3 over 2, find dy over dx. So dy over what? Dx. Dy over dx will be equals to what? That will be 3 over 2. X raised to power 3 over 2 minus 1. Okay? X raised to power 3 over 2 minus 1, and that becomes what? This is the same thing as over 1. So you can have 3 over 2 x to the power of 3 minus 2. That's the LCM of 2 and 1 is what? Is 2. How many 2 can we see? 2, 1 times this, that's 3 minus this, and this is 2 times 1 is 2. And that becomes 3 over 2. X raised to the power of minus, that's 1 over 2. 1 over 2. So this will be the y dx. Please do not write y. Okay? So we should have this to be equals to what? That will be the y dx equals to what? 3 upon 2 square root of what? X. So this is the answer, okay? This is the derivative of x raised to the power 3 over 2. This will become the coefficient x raised to the power 3 over 2 minus 1. That minus 1 is constant. Minus 1 is constant, please. After bringing the power to what? To become the coefficient, then take away 1 from the power. Constant. Minus 1 is constant. Then we have this, okay? And we have this. Very correct. Very correct. Very correct. So the last one on the list under this, let's look at this question 3. Question 3. Okay? If y equals to x squared plus 5x minus 6, find y prime. Good. Find y prime. Find y prime. What do you mean by y prime? Y prime is still the same thing as what? As dy dx. Y prime is still the same thing as dy dx. Note that dy over dx equals to what? Equals to y prime. Okay? A. B. Also note this, that f of x is still the same thing as what? As y. That f of x, function of x, is still the same thing as what? As y. And also take note of this, that f prime of x is still the same thing as what? Dy dx. Please take note that f prime of x is the same thing as dy dx. Okay, which is still the same thing as y prime. So we have to find y prime, still the same thing as dy dx. Okay, so we have solution y equals to x squared plus 5x minus 6. Okay, so we can have y prime, which is dy dx, equals to, take this one to the front, that becomes 2x raised to power 2 minus 1 plus, what do you have there? 1 is there. 1 is the power of what? Of x. Okay, that becomes 1 times 5, x raised to power 1 minus 1, yes or no, minus 0. Okay, the derivative of what? Constant. The derivative of a constant is equals to 0. Derivative of a constant will give you 0. This is what we call constant. Don't forget that, because it does not have any what? Variable. That is, the variable of this 6 is raised to the power of 0. That is x raised to power 0. That will give us 1 minus 6 times 1 is minus 6. So it does not have any variable. So due to that, this is called what? Constant. So it's regarded as what? A constant. So we should know that the derivative of the constant will always give us what? 0. So we can have y prime, which is still the same thing as dy dx, which is still the same thing as f prime of x equals to this will give us 2x raised to the power of 1 plus what? 1 times 5 is 5, that is 5x raised to the power 0 minus 0. 0 means nothing. That will be 2x plus x raised to the power 0 is what? 1. That's 2x plus what? Plus 5. So this is what we call y prime. Y prime and not y. Please take notes. Take notes. Y and not what? Y prime. Y and not y prime. Okay? Let's move further to from the first principle. This is somehow complex. But not really complex, but just somehow complex. From the first principle. From the first principle. From the first principle. Okay? From the first principle, question 1 under this. Find dy upon dx if y equals to x raised to the power 2. Yes. If y equals to x to the power of 2. start with this. Find the y dx if y equals to x raised to the power of 2. You want to find the y dx, don't forget that the y dx is what we call the slope or the intercept. Okay? The slope, not the intercept, sorry. The slope or the gradient. When you say intercept, intercept is where the graph cuts y-axis. That is intercept. Intercept, and intercept is different from slope. Okay? It's different from slope. So we want to find the slope or the gradient. So we know that from the first principle, not the direct method. Of course, if you actually want to use direct method, in OBJ is just 2x. To differentiate this is just 2x in OBJ. But in theory, please do not, if you actually want to find the y dx, if y equals to x squared, or to differentiate from the first principle, if y equals to x raised to power 2, please, you are not expected to use what? Direct method. You can only use direct method in what? In OBJ. Okay? But to write this now, say let there be increase in y by changing y, and increase in x by what? By changing x. This is what we call what? Change. This is what we call small delta. Big delta. Or you call it what? Big one, big change. Or you call it what? Increase. Increase or increase or increase. Please take notes. This is small increase. This is what called small increase. Small increase. Okay. This is derived from where? From Greek alphabet, which means what? Normal D. Normal D. That is D for dog. Okay. Compared to our alphabet, which represent normal D. Okay. Normal D. Just as we have alpha to be equals to A. Alpha is A, beta is what? Is B. Okay? Take note of that. Okay? Find this from the first principle. From the first principle, say let there be increase in y by what? By changing y, and increase in x by what? By changing x. So this will be y plus delta what? Delta y. That's the increase. Let there be increase in y by changing y, and also increase in x by changing x. So that will be x plus delta what? Delta x, all raised to the power of 2. All raised to the power of 2. All raised to the power of 2. So this will become what? Y plus 1 plus changing y equals to, expand this. Expand this. If you expand this will give us x squared plus 2x delta x plus delta x or what? All squared. Plus delta x or all squared. Okay? Okay? So we can make y the subject of the formula by taking, we can make delta y the subject of the formula by taking y to the other side. So it will be left with what? With delta y equals to x squared plus 2x changing x plus what? Plus changing x all raised to power 2 minus y. Minus y. Then what is the value of y? What is the value of y? Y is what? X to the power of 2. This and this will go. Okay? So we left it what? Dy equals to what? 2x dx plus dx all raised to the power of 2. Okay? So this will be dy equals to what is common there? The x is common. So the x is common into bracket. Since we're having the x outside, we left it what here? 2x plus with 1 dx. Okay? Divide through by this. So we're having dy over the x equals to 2x plus dx. So the next thing is lim the x tends to what? To 0. Lim what? Dx tends to 0. Once you put lim this to be equal to 0, then this will what? Will mathematically change to what? To small d. That's dy over dx equals to 2x plus 0. So anywhere you see dx equals 0, that's the meaning. So that will give us 2x. So this is dy dx. Okay? And that will be the answer. This is how to differentiate from the first principle by saying let there be increasing y by changing y and increasing x by changing x, then that will be y plus change in y increase, that is plus change in y equals to x plus change in x. Open this bracket, that will be x squared plus 2x dx plus dx all squared, then take this to the other side, that will become minus y. Y is what? X, so that will minus x squared. This and this will go. We will have the y equals to 2x dx plus what? Plus this. The y equals to this. Okay? Divide both sides by what? By dx. The y over dx equals to 2x plus dx. Leave dx tends to what? To 0. That is as dx approaches what? 0. Meaning that what? This will mathematically change to what? To d. To d. That will be dy over dx. This is not what? This is not called d. This is increase in y over increase in x, or you call it what? Delta y over delta x. This is not dy over dx. No. There's a difference between this d and this d. This is delta, or you call it change or increase. Okay? That's the symbol for delta, or you call it change. That is small change, or you can use it big change. Okay? Let's look at the last one under this now. Question 3. Question 3. This is somehow difficult, but it's very, very simple also. Okay? Differentiate from the first. Differentiate with respect to what? To x. From the first principle, y equals to x to the power of 3. Differentiate with respect to x from the first principle. So, same statement. Let there be increase in y by changing y and increase in x by changing x. So we can have what? Y plus what? Plus changing y equals to x plus changing x, or raised to power of 3. Okay? Expand this. If you want to expand this, what are the coefficients? Normally, you can open 3 bracket, but opening of 3 brackets, you will see your time. No time. So what are the coefficients? Just to expand this directly, we can have 1 x raised to power 3 plus, this will be 3x squared dx plus 3x dx all squared plus what? Plus dx cubed. Okay? You can expand this by opening what? 3 bracket. You still give you the same thing. What I use here is what we call Pascal triangle. I use Pascal triangle. Okay? Just expanded it directly. So which we can have y plus dy equals to what they are? This will be x cubed plus 3x squared dx plus 3x dx squared plus what? The x raised to power 3. Okay? The x raised to power of 3. Take this to the other side. Take y to the other side. It becomes what? dy equals to x cubed plus 3x squared plus 3x dx plus dx 3x squared dx plus 3x dx squared plus dx cubed minus y. Whenever any number or an alphabet crosses an equality sign, it will change to minus. What's the value of y? Y is x cubed. Okay? This and this will go. X cubed minus x cubed is 0. Okay? We left with what? With 3x squared dx plus what? Plus 3x changing x squared plus changing x cubed plus changing x cubed. So what is common there? That is changing y. What is common? Changing x is common. That will be changing x into bracket. We left it what here? 3x squared. This is outside. Okay? Plus, we have 2 of this inside. So we left it what? 1 inside. That will be this. Okay? Plus, we have 3 of this here. 1 is outside. So we left it what? With 2. Okay? So we divide through by what? By changing x. So we have been changing y over changing x equals to what? Equals to 3x squared plus 3x change in x plus change in x squared. Okay? Then the next thing is what? To lim, right? Lim, changing x tends to what? To 0. So now therefore dy over dx. This will change to dy dx. Once you write this statement, this increase in y over increase in x will mathematically change to what? Dy over dx equals to what? Equals to 3x squared plus 3x into bracket 0 plus 0 squared. Okay? And that gives 3x squared plus everything is 0. This is 0 plus 0. 0 means nothing. So 3x squared equals to dy over what? Over dx. This is how to differentiate from the first what? The first principle. So that is how to differentiate from the first principle. Please, you can try this on your own. Send the answer, okay? And send the answer in the comment box, please. So differentiate from the first principle. If y equals to 3x raised to power 3, 2x raised to power 3 from the first principle, please. From the first principle. Thank you and God bless you.